Hello everyone, welcome to my channel. Today I'm going to talk about another binary search problem. This time we want to find the first element greater than or equal to the target. So let's start with the example. So the input is a sorted array, and we have a target number. If we can find the exact element, return the index of the element. In this case, the exact element is 3 and the index is 1. Now, if there are duplicated elements, we want to return exactly the first element that is greater than or equal to a target. So in this case, we should also return the index of 1. We can now return the index of 2. Now let's look at example 3. In this case, the target does not exist in the array. However, we want to find the first element that is greater than or equal to the element. So the first element that is greater than 4 is number 5. So the index is 2. So in this case, we should return 2. In this case, there is no element of target in the array, and all the elements in the array is less than the target. So in this case, we should return the array.length, which is 3, because index 0, index 1, index 2 are all smaller than the target. So we are saying, okay, assuming that large element is after the array. In this case, when all the elements are equal to the target, we want to return the first index, which is the index 0. So now let's try to write the code. So in binary search, we'll start with left equals to 0, right will equals to nums.length minus 1. And default value is nums.length. Because if we cannot find any element that is greater than or equal to the target, then we should return nums.length, so which is return the value, which is the default value. So we have left and right. Now our left less than or equal to right. I want to find the middle index, which is left plus right minus left divided by 2. So now I want to compare. Is nums. If the middle element is greater than or equal to target, so this means this is a valid answer. So we updated the return value to be middle. Then we have evaluated all the elements starting from the middle to the right. So now we want to evaluate a moment to settle right equal middle minus 1. And we'll evaluate from left to middle minus 1. Because starting from middle to the right, we do not need to evaluate it anymore, because we already find the answer. In this case, the middle element will be smaller than the target. So all the elements from the left to the middle, including the middle, is invalid. In this case, we want to set left equals to plus 4. So I try to run these test cases. All the test cases have passed. Let's try to run the random test cases. So all the random test cases had also been passed. So let's look at the code again. In binary search, there are different templates. So I think the key idea is to use a single template to try and then solve all the problems. There are different templates that would initialize right tools, nums.length. Also, some templates in those cases they will be left less than the right, and the right will be updated differently. Or when they calculate the middle element, they will be differently. I think if we try to understand different patterns, we might be confused in different edge cases. So my goal is try to use a single template, which always checks the left and the right element, and both of them will be checked. And in the while loop, we always say check when when left is less than or equal to right, the loop will continue. If we wanted to heal, the key thing is every time we try to reduce the window size by 1. In those cases, because every step, no matter whether we're in the if part or in the else part, the window size will always reduce by 1. Then this window will always be reduced by 1, and the loop will end. It will not go to infinite loop. At some step, like let's say the left and right, the window size is 2, they will be reduced to 1, and when they are 1, they will be reduced to 0, and when 0, becomes -1, and this will break. Here, when we calculate the middle element, it will be like we're always using this formula. One purpose is to avoid the overflow. The second purpose is when right equals to left plus 1, the middle will be equal to the left. And in those cases, like right will be moving to the left -1, so the loop will break. So it can avoid the infinite loop problem. Yeah, that's all. I think in binary search there are also several other patterns I will try to introduce in the future. Hope this video is helpful to you. If you have any questions, welcome to comment. And if you like this channel, welcome to subscribe. Thank you.